Good morning, everybody, and welcome to our last Here Developer webinar of 2021. It's been a long year. Can't believe it's December almost time to start Christmas. So I'd like to thank you all for joining us today. I'm going to be joined by Marek from Here Technologies, who is a product specialist, and he's going to introduce you all to the topic of electrical vehicle routing on the Here Cloud platform. So we think that electric vehicles are going to be a key component of transportation in the coming years. We've already seen the recent legislation in the UK that EV charge points are going to be mandatory for all new builds. So we're going to see a lot of demand for apps and services in both the consumer and business markets for applications and services which can solve EV routing and navigation challenges. So yeah, we really think that it's advantageous to get these features integrated now to lead the way in the market space. So yeah, we're really looking forward to this one. And I know there's a lot to cover. So without further ado, I shall hand over to Marek, who will guide you all through the topic. Thank you.
Hi, good morning, everyone. You should see my screen shortly. Marek, Krysiuk. I'm located in Berlin, and I'm heading routing services at Here Technologies, and today I will talk about the EV routing, why we built this, which problems we are solving, and a bit how we are doing this in detail. If you would like to dive deeper, there will be part for detailed questions at the end of the presentation, and I will do this in the two parts. So first one would be I will just show some slides and give you some overview of what we are doing and which problems we are attacking, and then I will give a short demo. Okay, so key challenges for electric vehicles. So first of all, and those things mostly known for most of you, either you have electric car or not, because it's very popular topic. So first problem EVs are facing right now is reduced range, and the range wouldn't be a problem if not the charging times, and charging times would be less of a problem if we have more charging stations. So driving electric vehicle is getting easier and easier every month, but still there are challenges to overcome. So and the biggest one is the range anxiety. So when you are getting into electric vehicle, you don't always have this peace of mind that you will get to your destination with existing charge, or if you find the charging station. And even if you know where charging station is, if you will reach the charging station with the current state of charge. So all those problems and all the questions lead to the lower adoption of electric cars right now. So what we are trying to do here as a company is not constructing batteries or electric powertrains, but we as a company, we are trying to attack the problem from the data and the software side. So we are trying to build the route planning service, which takes away all your concerns about the charging, about the range, and we are trying to replicate navigation experience of traditional electric, traditional internal combustion engine car. So idea is that you will give us your destination, tell us where you would like to go, tell us a little bit about your car, and then we'll do the rest. So I put the routing from product perspective, and many of you probably are familiar already with our routing services offered by Here. And as you saw on the first slide, chapter in the slide deck is number 2, because I won't be talking about the details of the routing, but it's important to remember that everything, our strategy, our product strategy for EV routing is that every feature which we have in the regular routing is inherited by electric routing. So the computation itself, computation of electric routes, electric car routes is separate. It operates, it's much more complex, operates on the 2 graphs, on the map graph, on map data and the charging data. So it's a much more complex problem, but our product strategy is to deliver the same experience, the same scope of functionality as we are doing, as we are providing for traditional traditional cars, and it's true now, and it will be true in the future with the new features. And also, it would mean it would be true for other modes. So when electric trucks will be reality in the future, also EV routing will be enabled for electric trucks. Currently, this is supported for car mode only. However, certain functionalities already are available for different vehicle types. So to address the EV challenge, we actually be offering several solutions and several building blocks actually to electric vehicle solution. And the first, most obvious one is the consumption calculation, very precise consumption calculation based not only on the static values from a vehicle, but also from using map data. When we know consumption, we can draw the range map. So we can visualize how far we can go. But most importantly, we can achieve the goal of long route planning. So we are calling this multi-stop routing, where we are giving a user not only a route, but the whole trip plan with the information where to stop, where to charge, and how much to charge. So our EV routing provides computes detailed route plan and provides user detailed route plan with charging stations on the way, and information about the charging station technical capabilities like a socket type, charging speed, and computes the plan for charging according to the specifics of a battery system, according to specifics of power battery management system. So end goal is that route from A to B is as short as possible time-wise when we are talking about the time domain. Beyond the electric market is very fragmented and is still developing very quickly. So there are also electric car specific preferences. So one of the unsolved problems in electric vehicle industry is, for example, payment or variability of pricing of energy. So what we are offering also in our API, in our service, is also ability to customize your EV experience, customization of EV route planning by exposing the more options to select the preferred brands or brands which support payment methods which are available to a driver. So you can customize. We are not only calculating the plan, but we can also calculate the plan, but it's in the way that it's visible within your ability to use the charging stations. And it's not only based on socket types, but also other things which could be limiting factor to get access to the station. In the future, we would like to introduce also preferences beyond feasibility, but the actual preferences. So, for example, if you would like to charge at the points where you have some facilities, like for example a restaurant or good restaurant, we will take also this into account, and we create a plan, but it's not only feasible, fastest, but also pleasant for the driver. And one additional important thing, due to the fact that we have completely different algorithm, those routes can be not very intuitive for people who are switching from the traditional cars to the new types of vehicles and to electric vehicles. So we are offering also alternatives, so routes which are less optimal but more familiar to the users in terms of the shape, in terms of waypoints through or they are going through. So if actually you have, if driver's perception, if driver's trust in the software and the system is not 100%, we can offer also alternatives which are closer to the traditional route computation. So, and we can do this, all of this through knowledge of the map, which at here we perfected, but also we need to have information about a car, and we need to have 2 data points. So information about how much about the consumption. This consumption curve, it's nothing unusual for OEMs. It's something, for example, each OEM must provide to EPA for certification, for environmental certification, and this is based those consumption curves are used to compute standardized ranges. Of course, in reality, they are changing. They are very different. So this is usually what OEMs are providing are the most optimistic case. So we have similar concept. Difference is that those curves are 100% dynamic. So you are providing those curves based on the for each request, which means that you can adjust them on the go. And usually, typically, it's done by integration of our API within powertrain management system. So based on the continuous readings and predictions for the of the consumption, those curves are being updated, and we are updating dynamically route plan. So system is fully dynamic and fully adaptable. So it's not the design for any specific type of vehicle. It's designed, it has this built-in flexibility which allows you to adapt to different vehicles, different vehicle loads, different external conditions like weather, like tire pressure, and so on. So this is one data point that, of course, we are not asking this for the end user, for the driver. This data is exposed in the API, but it's coming from vehicles themselves. And the second one is battery characteristic. Is also dynamic. It doesn't have to be as it's not as dynamic. It doesn't have to be as dynamic as a consumption curve. However, for the sake of addressing differences and the battery wear over time, this also can be provided to the API in the dynamic way. And the charging curve gives us information about how much energy vehicle can accept and different charging levels. So this is the second parameter. When we have all of this, we can compute those ideal routes, or just or at least create range maps. So illustrate how far you can go. So this is, I will just showing here screenshots, but for the part where of calculating those ideal trip plans, I will switch now to the browser, and I will show you live demo in the web tool how those routes can be planned. So let me make a switch to my browser. Okay, I hope you can see. Yeah, you can see now a browser. So what you see here is a tool, our API tool to demonstrate API features of routing. So it's not the most user-friendly tool, but it has benefit of having all the API routing API options exposed, and in some cases even the ones which are pre-production. So if you would like to experience not only EV routing but also other routing modes and other features, explore them or construct request URL, you or your developers can use this demo. It's free of charge and accessible without any registration. But what I will use the tool today for is I will calculate a route for electric route equal to point. And let me use my home turf, so Berlin, and let's go to Munich, where actually some famous car OEMs are located. And let's compute the traditional route. So here you have a route between Munich and Berlin, which takes 6 hours, 15 minutes, 43 minutes is traffic. And this is for the typical vehicle. If I would like to do the electric route, I need to provide those consumption curves and charging curves, and we don't have a time for this. I will not do this. I won't do this item by item, parameter by parameter. I will use this magic button, which will set us with default values for the tool, not for the API. And now I will recalculate the route with those values, and now you can see that route was enriched with those points, with the charging points, where we are telling users, telling drivers, suggesting drivers to stop and charge a vehicle. And what is interesting about this plan, it's not only charging station search discovery, but it's also information. We are providing also detailed information about the charging plan, which I will show you in this graph. So what happens here, as you see that we are building the plan, charging plan for the user. So we are telling user to go to the first charging station and charge only to 64%, and then to 300 kilowatt charging station and only to 56%, because we see in the charging curve that the slowdown of the charging at the station is less beneficial than going to the next station and charge of the vehicle over to another charge level. So we are not bluntly selecting just a charging station, but we also suggesting the optimal charging level, which is required to have this optimal, the shortest, the fastest travel time for a given route. And for this plan, the travel time is 8 hours 14 minutes, and total charging duration for this vehicle is 1 hour 41 minutes. Honestly speaking, with the current vehicles, you will get the better results. We are using those default values on purpose, a little bit more pessimistic. So we are stressing algorithm more, and we can present with those values more use cases, more corner cases for different types of vehicles. So what we are doing here, we are using 80, as you see on the left, we are using 80 kilowatt a car with an 80 kilowatt battery. Our charging curve is a little bit tricky, also to stress a little bit the algorithm and show the differences, expose better differences in speeds, and we have also charging curve. So and our charging curve, it's quite realistic. So this is how the typical battery charging curve looks like. Usually at higher charges, this curve is even more steep, but this is something which can be adjusted with resolution of your choice here in the tool. Of course, you can set a lot of your own preferences, like the preferred charging stations, initial charge, what is your kind of stress level. You can say, you can state what would be the minimal charge at the destination if you would like to have a higher safety margin, and so on. So you can get a route plan which is fully customized to your vehicle and to your driving preferences. And I'm very sorry for being actually rushing so much, but we have only 30 minutes, and I wanted to have last 10 minutes for Q&As. Especially it's important because topic is known, so I'm just sliding on the surface, and I'm looking forward to your questions to dive deeper into the topic and maybe to more interesting and challenging aspects of electric cars and electric route planning.
Thank you, Marek, for your very detailed and interesting presentation. I certainly learnt a lot myself. I very much like how here is using location intelligence to reduce the EV anxiety, because that's a huge barrier, and how the API can accept those multiple parameters specific to to the certain vehicles, specific vehicles. Also, the web client you shared, That looked very useful as well. So hopefully our developers will use this to speed up development and testing. So that's all really, really positive. As we go through, please, if you could put any questions you have in the chat so we can take a look at those as we go through. So I've just got a few questions already. I take it that for customers that have navigation use cases, they can already use EV navigation in the latest SDK for SDK4 Navigate?
Yes, they do.
Fantastic. And does the API, Marek, does it have any presets for electric scooters?
You can set up the consumption model for electric scooters, and we will compute the range for electric motorcycles, but we are not offering multi-stop long distance for motorcycles, especially that I don't think that this is really a use case, and I'm not sure even if sockets are compatible with electric motorcycles. So yes, you can use the consumption calculation and range for any type of vehicle, including trucks, motorcycles, or even you can model your personal stamina and your food range with and model candy bars as your energy source. So this model, this setup, the API is very flexible, and it can be used not only for different vehicles, but also for different fuel types. So you can also use this for hydrogen or traditional gasoline. So yeah, it's a long answer, but short. Okay. Yes, for consumption.
Fantastic. Yeah, interesting about hydrogen as well. This is another thing that people are looking to develop. We obviously don't know what the future will bring. So yeah, flexibility is really, really important. So thank you for your answers. Okay, I have another question here from Richard. He says, how regularly are you updating charging station locations and info?
Excellent question. So we are updating on routing side our charging station catalog weekly. So every week you have new routing with new map data, including new charging station data.
Perfect. Yeah, I can imagine it's a constant need to update this information, especially as countries scale up with their infrastructure. And I'm sure you've got some good partnerships that also enable this. What is the status for EV routing for trucks? Is there much on the roadmap for EV truck routing, please?
Yes, it's we are very opportunistic with electric trucks. So electric trucks, in terms of range calculation, they are already supported today. When you have when we are talking about long distance, long haul electric route planning, this is a little bit more complex because, first of all, there is no infrastructure for electric trucks. There is no, you can in theory connect to the existing sockets, but the problem is that you cannot park at those charging stations. So this is the market which is a long haul tracking is market which will develop definitely in upcoming years. And we already have some partnerships with OEMs to be part of this journey and co-develop with them. So it's coming, but it's not something which is available right now. It's not only because of software side, but also infrastructure and vehicles themselves.
Absolutely, yeah. It's going to be next, isn't it? And it's very important that you have those key partnerships, so you can be there at the vanguard and grow that market. So that's a really interesting question. We've got a customer here asking, what is the availability of UK data for EV routing? They understand that Germany, for example, has pretty good infrastructure, but here in the UK, it's not. We don't quite have that infrastructure. So do you have a comment on that?
Actually, excellent question, and I didn't have time to show this, but we have a quite interesting approach to evaluate the coverage. So if you go to our developerhere.com page, there is a section in routing documentation about EV coverage, and we are classifying countries in 4 categories, like full plus, full, and so on. and we are computing this coverage looking at the density of the charging stations versus the density of the road network. And we are classifying the country to a specific group. I don't remember UK by heart, but if there will be another question, I can quickly look at this page. If not, developerhere.com, EV routing coverage.
Fantastic. It'd be brilliant if you could drop that link into us, or we can follow up directly and make sure we've got that. But no, that's interesting. We really hope that coverage is increasing in the UK. A few more questions. Is it possible to add custom charging POIs? So you could put something in and put the data in, sort of bring it yourself?
Depending on the scale. So we are in the few months ago, we had a plan to have this doing this at the scale, because customers were coming to us and saying that they would like to manage their own charging stations data. But as our sourcing capabilities and performance developed, most of those customers are dropping this requirement and going with our charging stations. So when we are talking about really at scale, when we are talking about the individual charging stations, so for example, you have your own private charging stations on the way, there is an option to enforce a certain charging station. So we can still create the plan of the mix of your preferred charging stop and public data. But this is really it's not a feature which allows you to manage large sets of charging stations. It's more user-facing feature. But user can set preferences for certain charging station stop.
Excellent. Yeah, we could probably speak in more detail on that one at future dates if customers are wanting to add data that's not already on the HERE platform. Just a couple more questions. Is it possible to interact with the charging station to book charging time so you don't need to wait in a queue?
Yes and no. So routing itself just creating a routing plan, and based on the routing plan, you can create a booking. So those bookings are not part. To do those bookings, you need to use the third-party API. But using our routing, you can create. We can give you information when you will arrive at this charging station, and also you can indicate the let's say charging level. If actually you have a good price at this booking at this station, you can ask our API that you would like to be at this charging stations with 2% of charge to use as much of capabilities of the station as possible. And then we will do this. We'll plan your trip. We'll plan the previous charging stations in the way that you will get to your desired charging station, booked charging stations at given time with a given charging with desired charging level, battery state level.
Thank you. I'll just do have a few questions. We might need to sort of get these answered offline now, so we're just sort of running out of time. There's an interesting one here I'd like to ask you. How is battery age and wear modeled? Real world performance would drift away from the OEM provided battery and charging models.
Very true, very true. And this is why we introduced this dynamic battery curve, battery charging curve. So all those parameters related to the both to the powertrain and battery management system are externalized. So as battery deteriorates, readings from the battery management system can be exposed to the API, and we are taking those parameters in route computation. So we are doing this by exposing all those detailed parameters, detailed information, which we can consume in the planning to in the way that it can be on very low level integrated in the battery management system. So all the changes, not only because of batteries is getting older, but when, for example, because of the temperature or battery is not performing as usual, this also can be provided to the API, and we'll take this into account.
Fantastic. No, brilliant. Okay, I'm just going to ask one final question, and then we'll have to take it offline, I think, yes, turned out to be quite lively on the questions, so do apologise, but we will come back to you. Does the recommended charging time for each stop take as a parameter optimal charging time for the lifetime of the battery, please?
This is in hands of users. So we are exposing parameter of maximum charging cap, because this is what usually it means for the battery life. Charging speeds, they can be, of course, if there is an option in the vehicle to change the charging speeds, not only charging a cap, then it can be again modeled by correcting the charging curve. So then you can charging curve can be modeled to have a slower speeds. But this is ultimately decision of the user which charging, let's say, which charging strategy will be chosen, and this chosen charging strategy can be used as a parameter in the routing API, and then will compute the optimal route based on the selected charging strategy.
Fantastic. So a company can have its own policy. No, that's been really, really informative. Sorry, we've gone a few minutes over. As I say, we're going to come back to everybody and answer the questions. So thank you very much for attending today, everybody, and for a lively Q&A session. And please contact us to continue the conversation. If you've got any queries about using EV routing services and you're looking to integrate, or you'd like a free trial of the services, you can have a play around with yourself, and you've got a project you want to consult with us about, please reach out to an account manager if you've got one, or you can contact the HERE licensing desk here at greymatter.com, or call us with the number on the screen. So yeah, once again, thank you very much to everybody for attending, and enjoy the rest of your day.